Based on our previous video, looking at all the 5 examples, we can make a conclusion. Basic molecular geometry. Molecules that has basic molecular geometry are all non-polar. Okay. When we draw a molecule and the molecule shows basic molecular geometry, that means that molecule is non-polar. That is our conclusion. Now moving into other examples, we have a few examples over here. Let's say I choose an example like water. Example, water. So we want to determine whether water is a polar or non-polar. So when we draw the Lewis structure, we will get 0H, H double dot. This is the Lewis structure of water molecule. So we can see here the central atom has 2 BP and 2 LP, total 4 electron pair arrangement. Or we say AB2E2. A stands for central atom, B stands for terminal atom, E stands for the lone pair. E stands for the lone pair. So you can check here, there is 2 lone pair, right? So AB2E2. Never mind. From our understanding, previous understanding, 2BP, 2LP, 4, the shape is V shape, or we can call band. So we draw the molecule following the band shape. So the basic, I hope you remember, the basic is tetrahedral. So I erase these two. I replace them with lone pair, one here and one here, right? This is hydrogen, hydrogen. Oxygen is more electronegative than hydrogen. Therefore, oxygen will become the negative pole, hydrogen will become the positive pole. And the bond dipole is from positive to negative, from positive to negative. As you all can see, the bond dipole is moving upwards, only one direction, moving upwards, only one direction. There is no direction in opposite. There is no bond dipole moving downwards. Therefore, here we make an important conclusion. The resultant bond dipoles cannot cancel each other. Reason? Reason very simple. We only have one direction bond dipole. There is no opposite direction bond dipole. So they cannot cancel each other. When they cannot cancel each other, our next conclusion is dipole moment is not equals to zero. Dipole moment is not equal to zero because they cannot cancel each other. Therefore, our conclusion, H2O is a polar molecule.